Hi guys, actually my previous video was rotated by 90 degree. I'm extremely sorry. So now let's move to the questions on momentum and impulse. So this time the problem is you have a mass m and a mass 2m. So this mass is moving with a velocity v and this is moving with a velocity v by 2. The question, so this is before the collision, but after the collision these two actually join together, so the total mass becomes 3m. The question you have is, how do you find the final speed of this system? The question is very simple. Why? Because simply you can use the conservation of momentum. So what is conservation of momentum before collision? So this is our before. So before collision, mv minus 2m times v by 2. Why this minus sign? Because this velocity is in the opposite direction, which is equal to the total mass 3m times the velocity u. You see this 2 and 2 can be cancelled. So mv minus mv becomes 0 is equal to 3mu. So from here I can say u equal to 0. So let's move to the next question. So the next question is, you have a wall, a frictionless wall. An air molecule comes and collides with the wall and bounce back. So it bounces with the same speed. The mass of the air molecule is m. The angle is theta with respect to the normal. The question is, what is the magnitude? What is the magnitude of the momentum change? The question is magnitude of the momentum change. How do you find the magnitude of the momentum change? It's not really difficult, because I can divide this velocity vector into two components before the collision. So this is actually v sine theta. So if I divide this before collision, the horizontal component becomes v cos theta. And similarly after the collision, the vertical become v sine theta, but the horizontal component become v cos theta. So what is the change in momentum? Delta p. I'll put magnitude. Okay, so along the vertical direction it's become mv sine theta minus mv sine theta. It becomes 0. What about the magnitude of the momentum in the horizontal direction, which become, we are actually talking about the magnitude, so I don't need to worry about the direction. So mv cos theta minus, these two are in the opposite direction, minus mv cos theta. So I'll get 2mv cos theta. I hope you got the way I did. So now let's move to the third problem. So the third problem is, you have a cart, big mass, big N, and there is a person. and his mass is m. So this person is actually moving with a velocity v with respect to this cart. So I'll use c to denote cart. So the velocity of this velocity of this person m with respect to cart is actually v. And let's assume with respect to earth, so if for an earth observer this cart is moving with a velocity u. So for an earth observer this cart is moving with this direction u. So to apply the conservation of momentum, we have to always make sure all the velocity components are in the same frame of reference, otherwise there will be a conflict. So I will find what is the velocity of this person with respect to the earth. So this can be written as v mc plus v ce. What is mc? mc is this way v, plus what is ce? C is in the opposite direction u. So with respect to earth, this person is moving with v minus u. So now let's apply the conservation of momentum. So what is conservation of momentum? Says the total momentum is conserved. So before collision is the momentum is 0, not the collision, before he start to move it was 0, but when he start to move with velocity v, this system, this big game is actually moving with u. So the final is this small m is moving with v minus u speed, v minus u, because v minus u is the speed with respect to earth. So we have to put not this v minus u, plus the big game is moving with u. Sorry, it's not actually plus u because the u is in the opposite direction, so I have to put minus u. So 0 is equal to mv minus, if I take u as a common factor, I can say small m plus big M. From here I can say this u is mv by small m plus big M. I hope you got the idea. Now just remember this, because I'm going to do another problem. We have to use, I will directly use this result. So this time the problem is a boat on the water surface. So the length of this board is actually 4 meters and the mass of this board is 200 kilogram, and there is a person on the back and he is actually moving forward to this part of the board, the front. So the question is, when he moves from here to here, what is the distance traveled by the board with respect to earth? What is the distance? So I don't know what is the distance it traveled. Okay, the distance means this back side. So let's say this distance is x. I need to find what is this x. And also it is given this person has a mass of 70 kilogram. So this is also given. So I'm going to use our previous result, mv by small m plus big M. Now instead of the velocity, I can replace the velocity, mean the distance over time. So this u is actually the velocity of the cart in the previous problem. So in this case the velocity of this board. So I can replace this u by x by t time the mass of the person is 70 kilogram divided by the total mass of the system is 270 times the distance traveled from here to here. The person traveled is 4 meter over time. So distance by time. So I can cancel out t and t. So I get x equal to 280 by 270, which is equal to roughly 1.04 meter. So now we'll move to the next problem. So the next problem is, it's quite simple. Again, you have a wall, a mass of 0.5 kilogram object. It's moving with 6 meter per second and bouncing back. So it comes back with 4 meter per second. So this ball actually was in contact with the wall for 0.2 seconds. So that 0.2 is the contact time with the wall. The question is, what is the change in momentum? What is delta P? Remember, this change in momentum is the impulse. So how do you find the change in momentum? Final momentum minus initial momentum. So the final momentum is actually minus 0.5 times 4 minus the initial momentum is 0.5 times 6. So if I simplify this, I'll get minus 2 minus 3, which is equal to minus 5 Newton second is the change in momentum of the ball. And the next part of the question is, what is the force exerted on the ball by the wall? So what is the force? So the question is, what is the force experienced by this ball by the wall? So how do you do this? So remember, the impulse is F into T is actually delta P. Delta P means mv minus mu, change in momentum. So we just found this, the impulse. The impulse is minus 5, which is equal to force into this ball was in contact with the wall for 0.2 second. So the force now can be obtained by minus 5. I have to divide by 0.2, which is minus 25 Newton.